In this video, we're going to take a look at the normal distribution and use it as a way to organize data. So the mean and the standard deviation are going to be the important parts of this. They are considered bell-shaped curves. The mean, we're going to use the mu symbol, standard deviation, this other symbol here. The area under the curve is always equal to 1. So this is going to give us probabilities or percentages depending on how we look at it. So it's 1, and then we can look at it as 100% of the area if we're going to look at the percentages. Although we're going to talk about all the breakdowns of the percentages, 50% of the data is left of the mean, 50% is right of the mean. And then we have 3 more general ones. 68% is within 1 standard deviation. 95% is within 2 standard deviations. And then not quite 100%, but 99.7% of the observations fall within 3 standard deviations of the mean. All right, so I'm going to label this actually with numbers and then talk about what that means underneath. I'm going to put a 0 underneath where it says mean. And then we have standard deviations to the right and to the left. So I'm going to do plus for the right and minus for the left. Right, and then the percentage breakdown, if we go 1 standard deviation to the left and right, and actually in top, I'm gonna add in some words. This should say centered about the mean. So if the first standard deviation is 68% and we cut that in half, we're gonna get 34 and 34. And then the rest of the breakdowns go as follows: 13.5, 2.35 in the next one, and then the last is going to be 0.15%. All right, so what we're going to do is we're going to look at some different scenarios with the mean and standard deviation, and then make some conclusions about the data. So in our first one, we're going to draw a normal curve with a mean of 25 and a standard deviation of 5. So we're going to put 25 in the middle, and then we're going to add 5 going to the right, subtract 5 going to the left. In the beginning, I also usually recommend writing down the breakdowns of the different percentages. We don't really need them for these first couple questions, but you can put in the 34, depending on the complicated aspect of the question, might determine needing that or not. So the percent of data that lies between the 15 and 35, since those are both 2 standard deviations away, that's going to be our 95%, where you can add up all the percentages in between. The percent that is less than 25, since 25 is the mean, would be the 50%. So again, coming from those basic ones on that first page. All right, our next one is a scenario, and then instead of looking at percent, we're going to look at how many of the eggs are going to hatch. So we have incubation time for Rhode Island red chicks is normally distributed with a mean of 21 days and a standard deviation of 1. So we'll put 21 on the mean, add 1 going to the right, subtract 1 going to the left. All right, so now it's telling us if 1,000 eggs are being incubated, how many chicks do we expect to hatch in 19 to 23 days? When it comes to how many, we actually need to take the percentage and do the probability first. So 19 to 23 is, again, the 95%, because you're within 2 standard deviations. So if you switch it into probability, which is 0.95, and then multiply by the 1,000, you get the amount of eggs that will probably hatch in that time. And these are all probabilities and estimations, so that's an approximate number, not necessarily exact. And then same situation in the next one between 20 and 22 days. That's within the 1 standard deviation, so that's our 68%. So we get approximately 680 eggs hatching within that time frame. Right, and then the next two, same idea, they're just on the next page, which is a little bit annoying, but 1,000 eggs are being incubated. How many chicks do we expect to hatch in 21 days or fewer? 21 is our mean, so that would be 50%. And then between the 18 and 24 days is our 3 standard deviations, which is the 99.7%. So I'm going to fill that in on the next page, but just so that you can see it, you might want to keep your paper open while you're looking at that. So that's the second way that the question can be asked. You can be asked for the percent. You can be asked for how many of something would occur over those different, in this case, time frames or other types of standard deviations. And you can also be asked about probability. So we'll look at that in our next example in one of the parts. So this last one here, before we do a second video about the calculator, the yearly wheat yield per acre on a particular farm is normally distributed with a mean of 35 and standard deviation of 8. So put the 35 in the middle, add 8, and subtract 8. All right, and then it asks us find the percentage of area over the interval between 19 and 35. Now, because this interval doesn't span the exact centered about the mean of 1 standard deviation or 2 standard deviations, we want to add up the specific percentages. So if I add up the 34 and 13.5, I get 47.5%. Now the second part's not asking you a new question, it's just asking what the probability would be. So you're going to change the probability, the percent into probability. You have a couple options. You can divide by 100. Or you can move the decimal over 2 places to the left. Both essentially are doing the same thing, but probability should be between 0 and 1, so you would have to divide out the 100 to get that. And you're starting out with the percentages always, and then translating it into the answer that we're looking for.